Hello, this is Ms. Park. This video is going to show how to expand and simplify algebraic expressions, and it's meant for grade 10. So expand and simplify we saw before in grade 9. Okay, so in grade 9 we did collecting like terms like 2x plus 3x minus x. That would equal to 4x. Okay, but we also did, sorry, grade 9. We also did expanding. So if you had an expression, so let's say x plus 3, and you had a number in front, that meant multiplication. So this 2 is being multiplied by everything in the bracket. And the way we did this is we expanded. We said, okay, that's equal to 2 times x plus 2 times 3, which is equal to 2x plus 6. And then we had sort of more complicated expressions that went kind of like this. And then we had like other coefficients inside like that with negatives. And we would do the same thing. We would expand all of this and collect the like terms. And then we would have our final answer, which is fully simplified. So what's different in grade 10 is that now instead of just being a single number times a bracket, you have a bracket times a bracket. So for example, we have x plus 1 times x plus 3. So that's what this video will be about. So I'm going to start by sort of visualizing or demonstrating with a visual what expand and simplify meant in grade 9. So let's take, for example, 2 times x plus 3. I'm going to draw an area model. Okay, so an area model is a picture that allows us to represent algebra using the concept of area. So if I draw a rectangle, okay, where the dimensions are 2 times x plus 3, like this, okay, then the area inside is what I get when I multiply 2 times x plus 3. So how do you figure out the area inside? Well, we can split this x plus 3 into 2 parts. And the first part gives me a rectangle where the dimensions are 2 by x. So that's going to be 2x. And the second rectangle gives me an area that's 2 by 3. And that's so 6. And so when you add up, when you have a rectangle and you know the areas of the pieces, you can add them up to get the total area. And that's going to be 2x plus 6. Okay, with algebra or with the sort of the steps that we did, we just did this distribution. And we said that's equal to 2x, and then plus 2 times 3 is 6. All right, so that was before using the area model. Now I'll give you a different one. Let's go x plus 1 times x plus 3, and we'll use the area model. Now, because each of these brackets has 2 terms in it, my rectangle is going to be 2 terms by 2 terms, like this. And so here I have my x plus 1, and here I have my x plus 3. And now I'm going to fill in the parts, and then my area is going to be what you get when you multiply the length times the width. So first rectangle, x times x is x squared. Second rectangle, 3 times x is 3x. So how am I doing that? This dimension is x, this dimension is 3. So that gives me 3x. Next one, this dimension is 1 and this is x. That gives me 1x. And I won't write the 1. You can, but you don't have to. Okay, and the last one is going to be a 1 by 3. So that's going to be 3. And when I add up all the areas, I'm going to get x squared plus 3x, right? I'm just adding up the rectangles inside, plus another x plus 3. And when you collect the like terms, you get x squared plus 4x plus 3. All right, and that's the multiplication. So you end up really with 4 parts. Because 2 of the parts are both terms that have x, when you collect the like terms, you end up with 3 terms. Algebraically, what you could do this without drawing a picture is you could recognize that in the picture, each term in the first bracket is multiplied by each term in the second bracket. Since you have 2 terms in the first and 2 terms in the second, you have a total of 4 multiplications to do. What were those 4 multiplications? Well, first it was x times x, that's x squared. Then it was x times 3, so that's 3x. Then it was 1 times x, so that's x. And then it was 1 times 3, and that's 3. And then we add them up and collect the like terms. So that's how you do it without the picture. I'm just going to change color for a second. So there is a name for what I just did here with these multiplications with the brackets, and it's called FOIL. Okay, FOIL is an acronym that reminds us what gets multiplied by what. So what did I do first? I did the x by the x. We call that F because it's multiplying the first terms in each bracket. So that's the F in FOIL. Then what I did is I multiplied the x by the 3. We call that O because that's multiplying the outside terms in each bracket. Then we multiplied the 1 by the x, and we call that I because those are the inside terms from the brackets. And then finally, the last one is called L because 1 times 3, those are the last terms in each bracket that we multiplied. So FOIL stands for first, outside, inside, last. And it's just a way to remember that there are 4 multiplications to do. All right, now I may not use the word FOIL in my lessons. I may just say distribute, or I may just say expand and simplify. But if you hear the word FOIL, that's what it means. It means multiplying them in this order, making sure that you have 4 multiplications. Okay, let's do another example. This time I'll throw in some negatives. So let's go 2x minus 1 times 3x plus 5. Okay, I'll do it first with the area model, and then I'll do it without the area model. So first one, we're going to make our brackets, and we're going to go 2x minus 1. Now it doesn't matter the order, which one goes along the length and which one goes along the width, because it's just multiplication and order doesn't matter. But what's interesting here is that you can have a length that's -1. Right? We're just going to have to be okay with that that side length is -1. That doesn't happen in regular rectangles, right? But it does in algebra. Anything can happen in algebra. So the first box is 2x times 3x. So we multiply 2 times 3 is 6. X times x is x squared. 2x times 5 is going to be 10x. Now, the next bracket is -1 times 3x, so I'm going to put that negative in there. I mean, we could put the positive in the 10x too. And then the last one is -1 times +5, which is -5. So altogether, you're going to get 6x squared plus 10x minus 3x minus 5, which is 6x squared plus 7x minus 5. All right, let's do the same question without the picture. So first I'm going to multiply these two. 2x times 3x is 6x squared. 2x plus 5 is 10x. -1 times 3x is -3x. -1 times 5, -5. Collect the like terms, right? These are the like terms. 6x squared plus 7x minus 5. Right? So even if you have some of the side lengths are negative, you can still do this math. Shall we do it in general? If I have, let's go over here. If I have 2 brackets, a plus b times c plus d. Okay, no numbers, just letters. Right? Area model. This is a, b, this is c and d. You can put the plus if you like. First bracket is AC, second bracket AD, third bracket BC, last bracket BD. Using distribution, A times C, AC, A times D, AD, B times C, BC, B times D, BD. Right, so let's take this one step further. So this is the basic, okay? So now we're gonna get a little bit advanced here. What if I had 3 items here? 2x squared plus, sorry, let's not go 2x squared. Let's use different variables. Okay, so let me go 2x plus 3y plus 1 times x minus 1. You know, that's a lot of stuff, right? But all that happens is if I was going to make the rectangle, then it would be a 3 by 2. And this would be 2x, 3y, and 1. And this would be x and minus 1. And you would just fill in all the rectangles. So 2x squared, just doing all the little areas. -2x, 3xy, -3y, x, and -1. And then we would add up all of those things. Okay, let me switch color and let's do it with distribution. 2x times x, 2x squared. 2x times -1, -2x. 3y times x is plus 3xy. 3y times negative 1 minus 3y. 1 times x is plus x. 1 times negative 1 is negative 1. Notice there are 6 multiplications because I have 3 things in the first bracket and 2 things in the second bracket, and each item from the first must be multiplied by each item from the second for a total of 6 items. 6 multiplications. Let's look for like terms. I think I only see this one and this one. Those are the only like terms. So then we're going to write 2x squared plus 3xy minus x minus 3y minus 1. All right, and then one last thing. Actually, you know what? 2 things. What if I had a number out in front? Negative 2, x plus 4, 2x minus 5. So now I have 3 things multiplied. So when you have 3 things multiplied, the order in which you multiply them doesn't matter. So I'm going to multiply these 2 first, and then that answer will be multiplied by negative 2. So let's go. Distribute. X times 2x is 2x squared. X times negative 5 is minus 5x. 4 times 2x is plus 8x. 4 times negative 5 is be a minus 20. Collect the like terms. So I got these x's are like terms. So I got 2x squared plus 3x minus 20. Now that whole thing is times negative 2. So now I need to distribute the negative 2. Negative 4x squared minus 6x plus 40. And that's it, simplified. Okay? Your very, very last example is what happens if I have a bracket that looks like this, 3x minus 5, the whole thing squared. Right? So we know when a number is squared means it's times itself. So that's the same as 3x minus 5 times 3x minus 5. And so we'll do the same thing, 3x times 3x, 9x squared. 3x times negative 5 is minus 15x. Negative 5 times 3x is minus 15x. Negative 5 times negative 5 is plus 25. 9x squared minus 30x plus 25. Okay, so hopefully you've seen enough examples now that it would help you with any questions that you're faced that have to do with expand and simplify. Sometimes the expressions get really long, but that's okay. Just do the multiplications and collect the like terms at the end. Okay, and that's it. So keep practicing. Thanks for watching.